Hi everyone, this is a brief overview of Vapor's Geometry tab, which describes where in the scene we are rendering for a particular renderer. Just a little bit of a recap, Vapor is a tool that's a desktop application comprised of about 10 renderers, or that's what we call them. Each renderer draws your data according to different properties of color, opacity, and different parameters in order to create your 3D rendering. And so this is a overview of one of the crucial components of every renderer in Vapor, the Geometry tab. It shows you where you're drawing to within your simulation domain. So just to elaborate a little bit more, I described this in other tutorials, but what Vapor's main control system is comprised of is a series of tabs. We can see Vapor, a small window. Over here on the right, we have a rendering. Over here on the top left, we have our current instances of our renderers. And over here on the bottom left, we have our variables, appearance, and geometry tabs. There's also the annotation tab, but the important ones are the variables, appearance, and geometry. In this talk, we'll be talking about geometry, but just as a quick recap, the variables tab controls what we're rendering, what variable we've selected from our simulation to create a rendering out of. The Appearance tab, over here to the right of the Variables tab, describes how we're rendering. So what colors, what opacity values we're applying to our rendering, and many other things. But this talk is mostly about the last one. To the right of the Appearance tab, we have the Geometry tab, which allows us to specify where we are rendering to in our visualization. And so one example of how that could be applied is over here on the left. By default, all of the renderers are going to draw the data within the entire domain. And so here we can see on our white rectangle, our entire domain is being rendered to with this volume renderer. But with the Geometry tab, we can restrict the data that we're rendering to into some kind of slab or subsection. So with that all being said, for demonstration, I think the first thing I have to do is scroll down to the bottom of my window. I'm on OS X and I have Vapor linked right down here, so I'll click that. Close my notification dialog, and here's our base state of Vapor. The first thing we always do is go to File, and we have to get data into it somehow. So I'm, in this case, going to go to Import, WRF ARW. Navigate to my WRF directory, and select that guy. And now we can see our domain. I can right click to zoom out, left click to rotate, and so far so good. The first thing I will do next, or the second thing I'll do, is click on the New button to create an instance of a renderer. So I've clicked on New. I'll go down to the volume. This example will be of a volume renderer, applying the Geometry tab within a volume renderer, and I'll click OK. Now that I have my instance of my volume renderer up here in the table, I can enable it by clicking on this checkbox. And there's our first volume rendering, but the problem with this data set is that the values for our current variable, again, we have our variables tab, appearance tab, and geometry tab. The default variable for this data set is all zeros, and so it's not going to show anything of interest. So I'm going to change my variable in my variables tab by clicking on the variable name option, and I'll go to QVapor. And there's our default volume rendering. We can see it's mostly a static field going up on the z-axis, but there is a little bit of interesting turbulence going on down here. So I guess to demonstrate the geometry tab, I will next go from my variables to my appearance to my geometry tab. And from here we can see when I click on my geometry tab, in our main rendering, these handlebars show up. We can see one at the top and on the sides. If I rotate, we can see one on the bottom. And there's basically a handlebar that controls the region we're drawing to within the scene. That's the first way we can control the region we're rendering to. But the second way is also over here in the control panel. So just to get on with it, I'm going to go ahead and right click on this handlebar, And if I control the region this way, again, this is a right click, not a left click. I right click on it, I can constrain the data values on my grid that I'm drawing to. So if I want to look at a slab, I can right click these handlebars and slide them to get a more visually interactive control system of the region I'm drawing to. So that's one way. Once we activate the geometry tab, these handlebars get shown. Again, if I go to my variables tab, they go away. Back to the geometry tab, they show up again. Right click, and I can visually control them. Another way I control the region is in this region tab we have over here. So we have under geometry, we have a section called region with these slider bars. There are two handles on each side, so I can left click on a handle and extend my region. This is on the X, Y, and Z axis, represented by a minimum value and a maximum value. And so again, I can grab these handlebars and control the region that way. I can also click on the middle region of these handlebars and traverse my region forward and backward. So the size of the region when I click on the handle is remaining the same. Like, so let's say if I had 4,000, let's make this guy 2,000. Now we have a region that is between 2,000 and 4,000 on the z-axis of size 2,000, and I can drag that up and down as needed if that's what I need. And so those are the two ways to control the region with these handlebars visually in the visualizer, and also in this region tab where you can control the region by handlebars or discrete values. There are a couple of other things we can do in our geometry tab. We can copy a region from a renderer, and we can also transform our region. And so I'll demonstrate this guy up here, copy region from renderer, which means that if you have a region in an isosurface renderer and you want to duplicate that region in a volume renderer, you can select it from this drop-down menu. And so to demonstrate that, the first thing I need to do is have at least two renderers. We need a renderer that we're copying from. So I'll click on New, create a new isosurface renderer. And so now we can see we have an isosurface renderer and a volume renderer up in our table. Our isosurface renderer, when I click on that, we're still in our geometry tab, and we can see our handlebars show up, and the default region is the full region of the domain. If I wanted to, let's turn off of our volume renderer, turn on our isosurface renderer, and then also select the same variable. So I'll go to my variables tab, select Q vapor, and there we have some isosurface. It's not a very interesting one, but if I go back to my geometry tab, we can see that the full domain is set as the default, whereas if I select my volume renderer, that's the region that my volume renderer is being restricted to. And so clicking on my isosurface renderer again, if I want to copy the region of my volume renderer, I've selected my isosurface renderer up here in the table, and I can select my volume renderer from the drop-down box right here, volume, copy it, and now we can see if I go between my isosurface renderer and my volume renderer, they occupy the same region. And if I turn on my volume renderer, we can see that my isosurface is almost completely occluded. You can see a little faint trace of it around the edge, but both of them are being drawn to the exact same region because I copied the isosurface region from my volume. The last thing I guess we'll talk about is the transform window. So let's see. For demonstration purposes, I'm going to go to my volume renderer, turn it on, and I'm going to make it render here towards my base. So now they don't share the same region they're drawing to, but I think this is just a better demonstration if we can see both renderers at the same time. So I've activated my volume renderer, and I can translate, scale it, or adjust the origin. So with translation and scaling and origin, we can do all these operations on the X, Y, and Z axes. And just for demonstration purposes, my volume renderer can be translated by 1,000 meters on the x by typing 1,000 in, and we can see it jump over on the x-axis. Same for y, and the same thing for z. For demonstrating the scale, I'll go to my isosurface renderer, and we'll be doing different operations on this. And the whole reason that you would want to use these is that if there's a problem with alignment between multiple data sets, usually I've never seen a use case where a single simulation doesn't have alignment between two different variables, even though they can happen on staggered grids. But I think there's a few edge cases where it might be helpful to transform an individual renderer. So for the isosurface renderer, the transform we'll be doing is the scale function. I'll click on this 1, make it a 2, and we can see that on the x-axis, my isosurface is now doubled. I can do the same thing on the y, doubling it on this axis, and I can also do it on z. So those are the basics of the geometry tab. It's a more simple tab than the appearance tab. Basically, it just allows you to look at a subset of your domain if there's something in the way and you're looking at a more interesting feature nestled inside of your larger volume. So thank you for watching. If you have any questions, I'll put a link to our Discord forum at the bottom of this video, and I'll see you next time.